Hi, today we got Pearson Edexcel Functional Skills Maths Paper 6, Level 2, and we're going to start with the non-calculator section. Question 1. Jai needs to buy 25 lollipops for a party. He sees this offer. Lollipop selection bag, now 1/3 extra free. Jai knows a normal selection bag contains 18 lollipops. He thinks he will have enough lollipops if he buys a selection bag with this offer. Is Jai correct? Show why you think this. Okay, right. So we've got this selection bag with 18 lollipops. And we're going to get 1/3 extra free. So we want to know how much this extra bit is first. So we're going to say, well, what is 1/3 of 18? Or in other words, what we're saying is 18 divided by 3. So we can use our times table knowledge, or we can work this one out. So let's use our 3 times table. So 3, 6, 9, 12, 15, 18. So that's 6 times. Okay, so we've got 6 there. We already had 18 in the bag to start with. So we want to do 6 plus 18. Or 6 plus 8 is 14. 4 carry the 1. 1 plus 1 is 2. So we've got 24 lollipops. He needs 25. So 24 is less than 25. He thinks he'll have enough. Is he correct? No, he's not. He's going to be 1 short. Question 2. Here is a formula. We've got D equals 180, and then in brackets n minus 2, and all of that is divided by n. Find the value of D when n equals 5. Okay, well, let's substitute the 5 in for the n. Or in other words, we write the formula exactly the same. Although what I'm going to do here, well, we've got 180 next to the brackets. This means times, so I'm just going to put the times sign in to remind ourselves. Now, instead of the n, we can put the 5 minus 2, and all of that is divided by 5. Right, so we need to use our BIDMAS rules to remember what we do first. So the B in BIDMAS stands for brackets, so we do this bit first. But we're still going to keep the order the same, so we're still going to have the 180, it's just we're not doing anything with it. But 5 minus 2 is 3, so we can put that in. And all of that is divided by 5. Okay, now we can do the 180 times 3 bit, because we do multiplication next. So BIDMAS, so B-I-D-M for multiplication. Well, you could say the D comes first, but because this is all in the numerator, it's as if this is in brackets. Okay, so we need to do this bit first. Okay, so 180 times 3. Well, let's do 18 times 3. I'm going to ignore that 0 for now. So 3 times 8, we've got 8, 16, 24. And 1 times 3 is 3. Add the 2 is 5. So we've got 54. But we had a 0, so we can just put the 0 on the end. Okay, so we've got 540, and all of that is over 5, or divided by 5. So this bit, let's do this using the bus stop method. So the 540 goes in the bus stop, and the 5 is waiting outside. So how many times does 5 go into 5? Well, that's easy, that's once. What about 5 into 4? Well, 5 can't go into 4, because 5 is bigger than 4, so that's a 0. But we carry the 4 across. How many times does 5 go into 40? 5, 10, 15, 20, 25, 30, 35, 40. So that's 8 times. So our value of D is 108. And we can write that in there. Okay, question 3. Andrew is a member of a walking club. He sees this sign next to a footpath. So I've got this sign here. Glossop, 4 3/8 miles that way to the left, and New Mills, 5.5 miles to the right. Andrew will walk from this sign along the footpath to Glossop. So he's going to go that way to meet his friend. They will then walk back along the footpath to the sign. So then they're going to walk back to here and then onto New Mills. Then onto there. Work out the total distance that Andrew walks. Give your answer as a mixed number. You must show you're working. Right, so if he's going to walk to Glossop first, it's going to be 4 3/8 of a mile. Then he's got to walk back to where this sign is. So he's going to do another 4 3/8. And once he's got here with his friend, then they're going to go to New Mills, which is 5.5 miles. So we've got to add these all together. Okay, right. So a couple of different ways you could do this. You could turn it all into improper fractions. I'm not going to do that today. Sometimes I would. What I'm going to do first of all is I've got my denominators the same in these two fractions. In fact, what I'm going to do first of all, I'm going to take away the whole numbers. Okay, so we've got 4 plus 4 plus 5. So let's treat those separately. So 4 plus 4 plus 5. Well, 4 plus 4 is 8, plus 5 is 13. Okay, so we've got 13 miles already. Then, so let's cross those off because we've dealt with those bits. Then we've got 3/8 and another 3/8. Well, when the denominator's the same, if we've got 3/8 and 3/8, well, that's going to make 6/8. So when the denominator's the same, you just add the numerators. Okay. And we've still got this plus a half. Okay. So now we've just got two fractions we need to add. Well, before we add these, this 6/8, we can simplify this. I know that because both the numerator and the denominator are even, so I know 2 goes into both of them. So if we divide top and bottom by 2, well, 6 divided by 2 is 3, and 8 divided by 2 is 4. So we've simplified this to 3/4. We've still got to add on, we've still got to add on the half, but half isn't, we're still going to have different denominators. So how can we turn the half into something with the same denominator as this? Well, to get from 2 to 4, we've got to double it. So if we double the bottom, we double the top. So this is multiplied by 2, top and bottom. So 2 times 2 gives us 4, 1 times 2 gives us 2. So hopefully you can see we've still kept the value the same. So with this, from the 6/8 to the 3/4, we've divided both top and bottom by 2. With the half to the 2/4, we've still kept the value the same, but we've multiplied the top and bottom by 2. But what that's done for us is it's given us a fraction where the denominators are the same. So that means the denominator in the answer will be the same as 4. 3 plus 2 is 5. Right, well, this is a top-heavy or an improper fraction. So let's turn it into a mixed number. Well, 5 divided by 4. So how many times does 4 go into 5? Well, once, and 1 left over. Right, so we've added the whole number parts to get 13 miles. We've added the fraction parts to get 1 1/4. So now we just need to add those two together. So we want 13 plus 1 1/4. So we can add the whole numbers. 13 plus 1 is 14. And we've still got that 1/4 left. And this is as a mixed number. So we've got the whole number part and we've got the fraction part. Question 4. A box contains bags of crisps. Each bag of crisps is either beef flavour, prawn flavour or cheese flavour. Beth is going to take at random a bag of crisps from the box. This table shows each of the probabilities that the flavour will be beef or will be cheese. Work out the probability that Beth takes a bag of prawn flavour crisps. Okay, so we don't know what this is. But with probability, what we know is that all probabilities, the total of them always add up to 1. So the probability of beef plus the probability of prawn plus the probability of cheese must equal 1. So if we want to know what the probability that she picks a prawn bag of crisps, well, we need to work out what number is going to make this add up to 1. So to start off, let's add the 0.4 and the 0.35 together. Now, what I like to do with decimals, well, we've got a different number of digits, we just put a 0 in as a placeholder. We'll add those together. So 0 plus 5 is 5, 4 plus 3 is 7, 0 plus 0 is 0. Right, so the probability that she takes beef or cheese is 0.75. So the probability she takes a prawn bag is going to be 1 minus 0.75. And again, I want to have the same number of digits up here, so I've got something to take away from, so I can just put 0.00. 0 take away 5, we can't do. So we're going to have to take one from over here. So the 1, we're going to turn this into a 0, and we'll hand the 1 across. We want to hand 1 across over here again, so the 10 will take 1 away to make it 9. This now becomes 10. So 10 minus 5 is 5, 9 minus 7 is 2, and 0 minus 0 is 0. So we get a final answer of 0.25. And if you want to check that, we can add the 0.25 to the 0.75. That should give us an answer of 1. Okay. Right. 200 workers are asked about the favourite drink they have at work. Some of the results are shown in the table below. Complete the two-way table. Well, we've read that bit. We don't really need to have that anymore. So let's just have the table in shot. Right, so with these tables, these two-way tables, all of the numbers in each row must equal the total. And all of them in the column must equal the total at the bottom. Okay, so it doesn't matter too much where we start, but you want to pick a row or a column where we've only got one value missing. So I'll look at this column. So 27, if we take away the warehouse numbers, we should be left with the office workers. So 27 minus 10 is 17. I did that first because that felt like a nice, easy one to do as well. What should we do next? Let's do this. Actually, let's do the columns because they've got fewer numbers and they might be easier. So let's do 46 minus 8. So 46 minus 8. Well, 6 minus 8 we can't do. So we take one from here and pass it across. 16 minus 8 is 8. 3 minus nothing is 3. So we can put 38 in here. Right, now we want to work out these two numbers here. To work out this one, first of all, we need to add up the number of waters and coffees. So 17 plus 8. Well, 7 and 8 is 15. 1 and the carried 1 makes 2. Okay, so that's the total of these. So we want to take the total of these away from this 88. So 8 minus 5 is 3. 8 minus 2 is 6. So we've got 63 up here. Now, for this last one, we could do the same as before. We could add these together and take them away from the 200. But now we've got these two, it's probably simpler to just say, well, let's add 63 and 64. Well, 3 and 4 is 7. 6 and 6 is 12. So we've got 127. And if we want to do a check on this one, we can add up the 27 and the 127 and the 46 and make sure that adds up to 200. I'll let you check that one yourself. Okay, part C. What is the probability that a worker choosing coffee works in the office? Give your answer as a fraction in its simplest form. So we're only interested in a worker choosing coffee A worker choosing coffee. So we're only interested in the ones choosing coffee. Well, the total of those is 46. And then we want someone who chose coffee who works in the office. So that's these 8 people. So 8 out of 46. Now they've said give your answer as a fraction in its simplest form. Well, what number goes into 8 and 46? Well, they're both even. So we can divide them by 2. So 8 divided by 2 is 4. 46 divided by 2. Let's do that with the bus stop method. So how many times does 2 go into 4? 2, 4, so that's twice. And 2's into 6. 2, 4, 6, so that's 3 times. So 4 over 23. And I don't think we can go any smaller than that. The way I know we can't go any smaller is because 23 is a prime number, so that's not going to have any more factors other than 1 in itself. So that's the end of the non-calculator section. Okay, so now we're on to the calculator section. Okay, question 1. Olivia plans to drive from Birmingham to Manchester non-stop. The distance is 87 miles. She has allowed 1.5 hours for the journey. What is the average speed she must drive to complete the journey in 1.5 hours? Okay, well, it might help if you know the relationship between speed, distance and time. If you do, you might know it using this handy triangle, where distance, we've got speed and time like that. And the way I often remember it is that distance is equal to speed times time. But the reason it's handy to write it like this is if we want to work out something that isn't distance, well then we can use this triangle. So in this case we want to work out speed. So speed is distance over time. Okay. Right, so what's the speed? Well, we don't know. That's what we're trying to work out. What's the distance? Well, it's 87 miles. And what's the time? Well, it's 1.5 hours. Okay, so we can use the calculator for this one. So we want 87 divided by 1.5 and we get 58. And we can put this in here. Now we've got a part B, which is a check. Use a reverse calculation to show a check of your answer. So when we're doing the check, we start with the answer 58. And before we divide it by 1.5 to get 58, so we're going to do the opposite, which is multiplying by 1.5. So I've still got the 58 in my calculator from before. Multiply by 1.5. And we get 87, that's miles per hour. And because it's a check, I'm going to tick it to say, yeah, I've checked that 87 agrees with the 87 in the question. Okay. Question 2. Brian is a sports reporter. Team A played 30 rugby matches. The table shows information about the number of tries Team A scored in these matches. Okay, so there were 3 matches where they didn't score any tries, 7 matches where they scored 1 try, 11 matches where they scored 2 tries, and 9 matches where they scored 3 tries. And that was a total of 30 matches. Work out the mean number of tries Team A scored per match. Well, the mean is the total divided by the frequency, or how many. Well, the total, this is the total number of tries. Okay, Okay, so we can't just add these up. It's not the 30, it's not the number of matches, it's the total number of tries scored. So we need to work this out. Well, if there were no matches, 3 matches where no tries were scored, well, in all of these matches, there were no tries. 7 matches with 1 try in each, that means there were 7 tries altogether. 11 matches with 2 tries, so altogether it was 2 times 11, which was 22 tries. And there were 9 matches where they scored 3 in each, so 3 times 9 is 27. So what we've actually done up here, this column is the number of tries times the number of matches, which means if we add these up, we get the total number of tries scored. So let's have a look at that using the calculator. So 7 plus 22 plus 27 gives us 56. Okay, so our total is 56. And how many? Well, it's the mean per match. Well, there were 30 matches, so it's 56 divided by 30, which gives us 1.8666. Well, what I'll do is I'll show that I know this goes on, but then I'm going to round it to 2 decimal places. 86. The next number is a 6, which is more than 5, so we're going to round that up to 1.87 tries. And we can write that in there. Okay, we've got another part. Brian wants to compare 2 teams. He knows Team A had a range of 3 tries, and Team B had a range of 4 tries. Which team is more consistent scoring tries? Explain why you think this. Well, the range is the biggest minus the smallest. So if you want most consistent, it's going to be the smallest range. So which team is more consistent? So we can say, well, Team A is more consistent. Because it has a smaller range than Team B. Full stop. Question 3. The head teacher at a school is organising for some Year 7 and some Year 8 pupils to go on a school trip. 72 people in total will go on the school trip. There will be 1 adult to every 5 pupils. The ratio of the number of Year 7 pupils to the number of Year 8 pupils will be 3 to 1. How many adults, Year 7 pupils and Year 8 pupils will go on the trip? So there's 3 things we're trying to work out. Okay. Now we've sort of got a couple of different things going on. We've got a ratio of adults to pupils, and then we've got a ratio of Year 7 to Year 8 pupils. So we've actually got 2 different ratios in this question. So we're going to have to do those separately. So to start with, we can use this first ratio. So with this one, we don't care how many Year 7 and how many Year 8 pupils we've got. We just care about the total. So if we think about this, and I like to draw my little table for a ratio question. So we've got adults, we've got pupils, and so we're going to have a total. So every 1 adult, we've got 5 pupils. So if we just had 1 adult and 5 pupils, we would have a total of 6. But we're told actually we've got a total of 72. So how many lots of this ratio have we got in the 72? So we can do 72 divided by 6. So in other words, this is 12 times bigger than that. So we're going to need to multiply this by 12, and this by 12. Well, 1 times 12 is 12. 5 times 12, you might know it, but we can use the calculator. 12 times 5 is 60. And we can do a check because 12 plus 60 should equal 72, which it does. Right, so we've worked out the total number of adults. Right, so that's fine, that's good, so we've done that bit. Now we want to know the split between Year 7 and Year 8 pupils. Okay, so I'll move this up a little bit. This is where we can use this ratio. So, Year 7, Year 8, and we're going to have another total. So we've got another little ratio table. So the ratio of Year 7 to Year 8 is 3 to 1. So again, think of the total. If we only had 3 Year 1s and 1 Year 8, that means we would have 4 children, or 4 pupils. But we know from what we've just worked out that actually we've got 60 pupils. So how are we getting from the 4 up to the 60? Well, if we take our 60 and divide it by 4, we get 15. So we can multiply these. So let's start off with 15 times 3. So we're going to have 45 Year 7s. Let's show that we're times it by 15. And 1 times 15, well, we don't need the calculator for that. That's just going to be 15. And again, we can check that 45 plus 15 does equal 60. So let's fill this in as well. So we've got adults, Year 7 pupils and Year 8 pupils. Well, the adults, that was this 12 that we worked out here. Year 7 pupils was the 45. And Year 8 pupils was this 15. Okay. Question 4. Josh drives a lorry. He is planning his route. On the planned route, there is a low bridge. The maximum height of a lorry allowed under the bridge is 14 feet. Josh knows the lorry is 4.2 metres high. Josh uses 1 foot equals 0.3048 metres. Will the lorry be allowed under the bridge? Show why you think this. Okay, well, we've got feet and we've got metres, so we want to convert one to the other. Well, this conversion goes from feet to metres, so we might as well go that way. So we've got 14 feet. If 1 foot is 0.3048, well, 14 feet would mean multiplying that by 0.3048. So 14 times 0.3048 gives us 4.2672, and that's now in metres. The lorry is 4.2 metres high. So the bridge is higher than the lorry. So will it be allowed under the bridge? Yes. Okay. In fact, we can write the yes in there. Use a reverse calculation to show a check of your answer. Alright, so let's start with the answer that we had, which was the 4.2672, and we'll do the opposite. So instead of multiplying by 0.3048, we're going to divide by 0.3048. And if we do that, we've still got this answer in here. Divide it by 0.3048. We do in fact get back to 14 feet, which is what we want. Okay. And question 5. Yasmin invests £4,000. For the first 2 years, she receives annual compound interest of 3%. So that's for 2 years. In year 3, she receives annual compound interest of 2.5%. At the end of year 3, Yasmin wants to buy a car for £4,500. She will use all of the investment and interest towards the cost of the car. Work out how much more money Yasmin needs to buy the car. You must show your working. So first of all, we want to know how much her investment is worth after 3 years. Okay, so she starts off with £4,000. In the first year, she gets 3% interest. So we multiply that by 1.03. That's going to add 3% onto the 4,000. Okay. But it's the first 2 years. So that means in the second year, she also gets 3%. So you can multiply it by another 1.03. In year 3, she gets 2.5%. So we're going to multiply it by 1.025. Now I'll show you where these numbers came from. So the 3%, or in fact what I'm using is this formula where we have 1 plus 1 over 100. Okay, some people might like to use this formula. I think I like to derive it myself, but that's fine. So the S is the 4,000. The I is the interest rate. Now we need it as a decimal. So what we've done here is we've taken the 3, divided it by 100. So we get our answer as a decimal. Now that would just work out the interest. We want the interest and we want the original amount as well. So we add on the 100, or like 100%. So we add on the 1. So really this is like saying 103% of the original. So all of the original £4,000 plus an extra 3%. So that works for the first year, the second year, and that third year, as I say, we've got 2.5%. So it's like 2.5 divided by 100, which gives 0.025. But then we add on the 1, because again, we've got the whole amount that's been invested. So we end up with something that looks like this, which we can type straight into the calculator. Let's move it up so we can see both. So we've got 4,000 multiplied by 1.03. So that's the value after 1 year. Multiplied by another 1.03, the value after 2 years. And the third year, remember we've got this 1.025. Okay, so her investment after 3 years is worth £4,349.69. She wants to buy a car for 4,500. So we need our 4,500 minus 4,349.69. And that's going to tell us how much is left. Well, I've already got this number in my calculator, so I'm going to put that in my calculator's memory. Now we can do 4,500. Memory recall. What do I do? Let's try that again. 4,500. Take away memory recall equals, that's better, and we get £150.31. You don't have to use your calculator's memory, but I think it's useful to know how to do it because it just means you don't have to type things in, so you've got less chance of making a mistake or rounding when you don't need to. Question 6. Let's move it up to actually see what the question is. Write down the coordinate of point A. Well, A is this one. So we want our x coordinate first. So this is the x. So we find this. So it's going to be -4. And the y coordinate is going to be -2. Okay. Part B says mark with a cross the point C on the grid so that angle ACB is a right angle. Right, well a right angle is basically like a corner. So something like that. So, well, if we've got our 2 points here, how can we get a right angle? Well, we could do, just drawing this on so you can see where the right angle is. We could have this point here, and then we'd have a right angle. But actually, we could equally have this point down here. Because we'd have a right angle down here. So don't do both, do one of them, but I'll give you both values so that you know that both would be correct. So this x coordinate is going to be the same as this one. So this is going to be -4, and the y coordinate would be 3. So you could have -4, 3 as the answer, but also we could have this one. So that was my right angle, wasn't it? The x coordinate is 1, and the y coordinate is -2. Okay. So for part A, we definitely want -4, -2, but for part C, this one down here, we can have that -4, 3, or 1, -2. Okay. Either one's fine. Part C. Write down the sum of the interior angles of a triangle. So what that means is if you've got a triangle and you add the angles together, they're always the same number. What is that number? And I know you're all shouting 180 degrees. Question 7. Carlos records the number of tweets his company posts every year on social media. So 2014 there were 452 tweets, 2015 there were 325, and so on. Find the median number of tweets. The median, that's the one in the middle. So I'm going to start by ordering them. So which is the smallest number? Well, that's 325. What's next? 2. This next one. We've got 3 in the 700s. This is smaller than this one, then this one, then this one. Right, so you don't have to do all of this. So now I'm writing them in order. So number 1 is 325. The second smallest was 452. The third smallest was 712. Fourth was 744. Fifth was 750. And sixth was 1022. So you might have some shortcuts you can do, but I like this. I just think it's a nice way to make sure you don't make any mistakes. So we want the middle number. Well, so we cross off the smallest and largest. And again, and because we had an even number of years, that means that we've got 2 in the middle. So we need to add them together and then divide that by 2. So it's like we're taking the mean or the average of the middle 2 numbers. So we've got 712 plus 744, which gives us 1,456, and then we're dividing that by 2. And that gives us 728. And a nice check is, well, it should be between these 2 numbers, which is correct. Now, if some people are using scientific calculator and you haven't put your brackets round, then you could end up with something different. So just make sure when you get your middle number, you just say, does that look sensible? Does it look reasonable? It should be between the 3rd and the 4th value, and it is. Okay. In 2019, 6% of the tweets were about job vacancies. How many of the tweets in 2019 were about job vacancies? Well, they've already told us it was 6%. So 6%, that's going to be 6 out of 100. And of always means times. So in 2019, how many did we have? 750 tweets. So this is 6%. In fact, I'll write this is 6% of 750, which we're writing as 6 divided by 100 times 750. So with the calculator, 6 divided by 100 gives us the answer as a decimal. So if you know it as a decimal, you can go straight to that and then multiply it by 750 and we get 45. I can put that in there. Question 8. Myra works as a volunteer at her local pony club. She is going to cover the front of the stables with paint. The diagram shows a sketch of the front of the stables. Okay, so we've got this shape here. Yeah. So they're telling us that it's 28 feet across the bottom, 5 feet up to here, and then this top bit is 4 feet. So it's the overall height, not the diagonal, but the vertical height. Myra will buy the paint she needs. Right, let's move this up. 1 tin of paint covers 7 metres squared and costs £6.45p. She uses this rule. The area in square feet divided by 10.764 equals the area in square metres. Find out the total cost of the tins of paint Myra will buy. Right, well, if we want to know the total cost, we need to know how many tins. To work out how many tins, we need to know the area, and we need it in metres. But before we can work it out in metres, we need to work it out in feet. Okay. Sometimes I would say to convert straight into metres, I'd usually say the first thing you should do is to convert. But because this rule that they've given us works with area in square feet, we need to work out the area first and then use this rule to convert. Okay, and also we haven't been told how many feet there are in a metre, so we can't do that conversion anyway. Right, so we've got to work out the area of this. Well, I don't know how to work out the area of this. What is this? It's a pentagon, I suppose. So what I'm going to do is say, well, actually, it looks like a rectangle with a triangle stuck on top. And I know the area of a rectangle because it's the length times the width. So if we do 28 times 5, we get 140, and that's in feet. Now, for the triangle, the formula is not quite as simple, but the formula for the area is half times the base times the height. Well, half is just half. The base, well, that's all the way along here, which is 28. And the height is the vertical height. So we're talking about this, which is the same as this, so it's also 4 feet. Okay. So we've got 1/2, or 1 divided by 2, times the base, which is 28, times the height, which is 4. So we get a total of 56 feet. And in fact, that's feet squared. I should have put that on here as well because it's area. Okay, so the total area is going to be 140 plus 56. So 56 plus 140, which gives us 196 feet squared. Right, so we've got the area in square feet. Now we want it in square meters, so we can use this rule here. So we take the area in square feet and divide it by 10.764. Which gives us 18.2088 blah blah blah. Okay, now we've got lots of decimal places there, so I'm going to keep it in my calculator. I've sort of rounded it just to write it on here, but I'm still keeping them all in my calculator. Okay, I don't want to lose any accuracy. So that's the area in meters. Now, if 1 tin of paint covers 7 meters squared, well, we want to know how many 7s go into this. So we want 18.2 blah 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 divided by 7. So let's say we can just keep everything in the calculator, divide it by 7, and we get 2.601 blah blah blah. Okay, that's how many tins of paint we need, 2.601. Now, you can't go into a shop and say, I would like to buy 2.601 tins of paint, please. You'll have to give them a whole number. So they're going to have to go up to the next whole number, which of course is 3. Because if we bought 2 tins, it wouldn't be enough. So 3 tins would cover it. Okay, so we've got 3 tins of paint. Each tin costs £6.45. So we can do 3 times £6.45, and that gives us £19.35p. So 6 marks here, quite a lot to do, but if you think it through, or almost think backwards, so start with that end and think, well, if I need to work out the costs, I've got to know how many tins. If I want to know how many tins, I've got to know what the area is. If I need the area in meters squared, but the units on here are feet, I'm going to have to work that out, use the rule, and you get there. Okay, next up, question 9. I'm going to move it here so we can just about see the chart as well. Leona works in a sock shop. The scatter diagram shows the number of pairs of thermal socks sold and the average temperature that month. So, for example, what should we pick? Let's pick, I don't know. Let's pick, they're not the nicest ones to read. All right, well, let's go with this one here. So when the temperature was here, well, that would be 3. So each of these must be 0.2. So when the temperature was 3.8 degrees, there were 50, and these must be 2s. 2, 4, 6, 8. 52 pairs of socks were sold. Okay. It's just good to kind of understand what the graph is showing us. Okay. Now the question says, draw a line of best fit onto the scatter diagram. So a line of best fit is a straight line that covers the area that the data's in, so we don't want to kind of go beyond my fingers. It follows the overall trend or pattern of the data. And we don't have to go through the points. If we do, that's fine. But we want to sort of be somewhere in the middle. So roughly, you want the same number of points above it as below it, which we sort of have there. Yeah, that looks reasonable. Okay, part B. Describe the correlation between the number of pairs of thermal socks sold and the temperature. Well, this line is sloping down, so you could just say there's a negative correlation. But if you want to say something a bit more, or you can't remember the exact term to use, well, you can look at the diagram and say, well, as the temperature increases, so as this is getting bigger, the number of pairs sold of pairs of socks sold decreases. If the line was sloping up, it would mean as one thing goes up, the other thing goes up. But sloping down, as the temperature goes up, the number of pairs of socks sold goes down. And part C. Next month, the predicted average temperature is 5 degrees. Leona needs to estimate how many pairs of thermal socks she will sell. Estimate the number of pairs of thermal socks she will sell next month. Right, 5 degrees. So 5 degrees is here. So we're going to draw a line up to our line of best fit. And then we're going to draw a line across. And this is going to be our estimate. As we saw before, we've got between 40 and 50, we've got 1, 2, 3, 4, 5 boxes, but we've got a difference of 10. So that means that each of these must be worth 2. So that would be 42, 44, 46, 48, 50. So our estimate for the number of pairs of socks sold is 42. Okay. Question 10. Chris has moved to a new flat. The grid shows a plan of the kitchen. Okay, so let's move it up so we can see the kitchen a bit better. Right, so we've got a doorway here, window here. We're told that these are the walls all the way around the outside, and the cupboards are these section in here. We're also told that 1 square length on the grid represents 0.3 metres in the kitchen. So that is 0.3 metres, one of those squares. Chris needs to put a fridge and a table in the kitchen. So a fridge and a table. The fridge will need a rectangular space, 90 centimetres by 60 centimetres, with the longest side against a wall but not against a window. The table will need a rectangular space, 60 centimetres by 75 centimetres, and be at least 60 centimetres away from the doorways, the cupboards, the fridge, and not against a wall. Got quite a few requirements. Draw the space for the fridge and the space for the table on the grid for Chris. Remember to label the items. Right, so remember with these types of questions, often there's more than one right answer. So there's probably going to be a range of places these things can go. So all of these measurements they've given are in centimetres. But this for the grid, they've given it in metres. So what I'm going to do is turn this into centimetres. And I know that there are 100 centimetres in a metre. So if we multiply that by 100, 0.3 times 100, we're going to get 30 centimetres. Okay. So in other words, where we said this was 0.3 metres, it's also 30 centimetres. So we can think about our fridge. Well, it's a rectangle, 90 by 60. So how many squares are we going to need? Well, if 1 square is 30, we want to say, well, how many 30s go into 90? So 90 divided by 30 is 3. So that's going to be 3 squares. And we can do the same with the 60. 60 divided by 30, that's going to be 2 squares. Okay, so that's for our fridge. So before we put it on, let's work out the same for the table. So the table is also a rectangle. And it's 75 by 60. Well, the 60 is going to be the same as the 60 up there, so it's going to be 2 squares. 75, well, we want 75 divided by 30, which gives us 2.5, so 2.5 squares. So let's think about where we can put them. Right, the fridge will need, well, we know the fridge needs to be 3 squares by 2 squares, with the longest side against a wall, but not against a window. Well, let's find somewhere out the way. We'll maybe have it by the cupboards. Let's put it down here. I'm going over the line so you can, hopefully it stands out. In fact, let's colour it in a little bit more. So as soon as the cupboards finish, the fridge is going to start. Because I don't say it can't be next to the cupboards. All they tell us for the fridge is that the longest side against a wall, which it is, the 3, and not against a window. Well, the window's over there. So the window's up here. Now we're going to work out for the table. Right, so we know the table is 2.5 squares by 2 squares. At least 60 centimetres away from the doorways. Well, we already saw that 60 centimetres is 2 squares. So we want 2 squares away from the doorways, the cupboards, the fridge, and not against the wall. So, well, let's put it somewhere. You put it somewhere in the middle of the room then. Let's see, what about if we put it something like that? So here, this is 2 squares away from the door, 2 squares from the cupboard, 2 squares from the fridge. Okay, so let's, again, I'll do it by hand just to make it show up a little bit more on here. 2.5, 1, 2 would be to here. Now, in the exam, I would say to do this with a pencil, so you can test it out, and if it's not quite right, you can rub it out and try it again. So we've got 2.5 squares by 2 squares, at least 2 squares away from the doors. Yeah, at least 2. 2's fine. 2 from the cupboards, 2 from the fridge, and it's not against the wall. Looks good to me. Okay. Question 11. Nigel is the secretary of a football club. He pays 3 match officials each week. He has this information for the payments he has made for the last 5 weeks. So in week 1 he paid £62.94, week 2 £47.12, and so on. The table shows the match fees and expenses the officials will receive in week 6, so that's down here. It tells us the total payment for each official is made up of a match fee and expenses. So this is the fee for each one, and the expenses, so it's their travelling. So how much money per mile? So that'd be like to pay for petrol or bus fare or whatever. Nigel pays 67% of the total payments for these 3 match officials. Nigel thinks the payment he makes in week 6 is more than the median payment he made for the previous 5 weeks. Is Nigel correct? Right, so a few things going on. We need to work out how much he pays them, and we also need to work out what the median is, so we've got something to compare. So maybe let's start off with the median. Okay, well, if you think of the median, we did a median question earlier in the paper, so let's put these payments in order from smallest to largest. So smallest is this one, then this one, then the 74, then 81, and that. So I could write them all out, but I know if I cross off the first and the fifth and the second and the fourth, I'm going to end up with this one. So if you want to write them out and cross them off, you can, but I know the median is going to be £74.80. Now we want to know how much he's paying for each of these officials. So, and then we're going to need to work out 67% of the total, but we'll do that after we've worked these out. So for the referee, it's £36 plus 46 miles, and it's 30p. So think of that as 0.30. Okay, so if you think there's 30p in a pound, if you're writing that as money, it'd be like that. Okay. So using bid maths, we're going to do the multiplication first. So 46 times 0.3, and then add on the 36. And I get £49.80. I'm going out into the margin a little bit. Let's show you that there. Okay, now we can do the same for the next official. So £27 he gets, and 14 miles, again at 0.3 pounds per mile. So we do the 14 times 0.3, so that'd be £4.20, and then add on the 27. So £31.20. And then for the last one, we've still got a £27 fee. This time we've got 23 miles at 30p per mile. So 23 times 0.3, £6.90, and then add on the 27, which gives us £33.90. So the total fee, well, let's do it from bottom to top as I've got this in my calculator. £33.90 plus £31.20 plus £49.80, and that gives me £114.90. Okay, right. So we've got 114. Let me write that down here. £114.90. He pays 60% of the total payments. So we want to multiply that by 67 over 100. Okay. So I'll start off with that bit. 67 divided by 100 gives me the answer as a decimal. Then we multiply that by the £114 90p, and that gives us 76.983. But this is money, pounds and pence. We can't have 3 decimal places, so we need to round it to 2 decimal places, which would be 76.98. Okay, so we've worked out the value. Now the final bit. Nigel thinks the payment he makes in week 6 is more than the median payment made for the previous 5 weeks. So that was this number here. So 76, is it more than £74.80? Yes, it is. So is Nigel correct? Yes. And finally, question 12. Tammy wants to make chocolate sweets. The sweets will be solid chocolate in the shape of a sphere, so like a ball. Each sweet will have a radius of 2 centimetres. Okay. Tammy will melt chocolate blocks to make the sweets. Each chocolate block is a cuboid, so let's remind ourselves what a cuboid looks like. That would it. 19 centimetres by 14 centimetres by 0.75 centimetres. Okay, so it's going to be quite a flat cuboid. All right, let's do a different. So it's going to be, say it's 19 centimetres by 14 centimetres by 0.75. So it's just going to be a little sort of flat chocolate like that. And that little bit in there is 0.75 centimetres. Okay, she has this formula. The volume of a sphere is 4/3 times pi times the radius cubed, where r equals the radius and pi equals 3.14. Tammy wants to make 45 sweets. She thinks 7 blocks of chocolate are enough to make 45 sweets. Is Tammy correct? Okay, so we've got to work out how much we need for all the sweets and also how much we've got from the chocolate, so we can compare the two. So let's start with the volume, because that's probably a bit easier. So the volume of one block is going to be, well, 19 times 14 times 0.75. Okay, right. 19 times 14, sorry, it's a bit dark on here, 0.75, which is 199.5, and that's centimetres cubed. Okay. Now, we've got 7 of these blocks, or she thinks 7 blocks are enough, so multiply that by 7, and we get 1,396.5 centimetres cubed. So that's how much she's got. So that's 7 blocks. Now we've got to think about the sweets. So they're spheres. Right, can I draw a sphere? So it's sort of a circle, but then if I kind of imagine we've got this sort of going through it with the radius. I don't know if that helps. But we're told that the radius is 2 centimetres. Okay. We don't have to draw it, I'm just trying to be helpful. I'm not sure if I am. But anyway, that's our sphere. So the volume of the sphere, so we want 4 divided by 3 times pi, which they're telling us is 3.14, times the radius cubed. Now the radius is 2. If it's cubed, it's times itself and times itself again. So if you haven't got a scientific calculator, it doesn't matter. So we're doing 4 divided by 3 times 3.14 and then times 2 times 2 times 2. And we get 33.493333. Again, I'm going to put that in my calculator's memory and I'll just write that down as 33.49 for now. And again, that's centimetres cubed. Now she wants to make 45 of these chocolates. So we're going to multiply that by 45. So I've still got it in my calculator. Times it by 45. Right, so we've got, let me see that. So 1507.1999. So let's round this to the nearest. Well, we had this one to 1 decimal place, so let's do the same. So 1 decimal place would be the 1, but it's a 9, so we'll increase it. So we've got 1507.2 centimetres cubed. Well, that is more than the amount of chocolate we've got. So, no, she's not correct. And that's the end of the paper. So, there are a couple of tricky questions in there. But if you do your homework, do your revision, I'm sure you'll manage wonderfully. So thanks for watching. Please subscribe to the channel so you get updated when I add more videos. Like, ask any questions, give me any comments, and I'll see you again soon. Thank you.